Hi, I welcome all of you in my today's lecture that is based upon correlation analysis, and my follow-up lectures will be on regression, linear regression and multiple regression. Correlation analysis is a statistical measure expressed as a number, and that number will always be between -1 and +1 that describe the size. Size means either the relationship between two variables is strong, medium or weak, and the direction of that correlation. The direction or it can be positive or negative between two or more than two variables, and these variables must be numeric. The correlation analysis not possible between two qualitative variables. A correlation analysis between two variables, however, doesn't automatically mean that a change in one variable is the cause of change in the values of another variable. Sometimes there are also another factor that also do the change in the second variable. We mostly do correlation analysis before performing the regression analysis to check what type of relationship exists between the two variables. For example, in this slide it is shown that with the increase in the smoking cigarette, because in x-axis we have smoking cigarette like 2, 4, 6, 8, 10, 12. So with the increase in the number of cigarette that people smoke, is there any relationship with the mortality rate? So as per this data, we are getting the information that yes, that the mortality is increasing with the number of increase in the cigarettes. So if we draw a line, the line is going towards the upward. So we got one information from this graphical information that the relationship is positive. Further, we have to find out the correlation coefficient either by formulas or by using the software, and you can see that the straight line is accurately, or you can say best fitting the data. So it is based upon, from this information we can decide that a linear correlation exists between the mortality rate and the number of smoking cigarettes. However, correlation is not a caution. It means that not always we have to go towards the trend. It means, for example, the presence of correlation between two variables doesn't necessarily mean that there's a relationship between them. For example, is it possible that with the rainfall we have an increase in the sales of olive oil? No, it is not possible. However, this data from the sales department is showing that yes, it is possible. So it is wise to make your decision based upon your judgment, knowledge, your expertise, not always on the results of the correlation analysis. A second example. This example is showing that with the increase in the machine temperature, the defects in the product increases. Yes, it makes sense, and then we'll have to again draw a line in order to get the information that whether then this correlation is positive or negative. So you must have to choose those variables in which there must be a relationship with the common sense, with the logic, with the some expertise. You can say yes, there must be a relationship between these two. It is also important to include all the important variables in the study. For example, here in this data it is saying that with the increase in drinking coffee, the mortality rate increases. Is it make sense? No. But however, we can make some judgment and we can make some illusions that smokers, they often drink too much coffee. So maybe the people who drink coffee, they may be the smokers, and this smoking will affect their mortality rate. So we are missing one main variable. Which one? Smoking. So it is recommended then include all of the variable, just like mortality rate, second one drinking coffee, third one smoking of cigarettes. So in this way we can get more information and logical information. After the correlation analysis, we perform the regression analysis. That is good at identifying the variables that are significant and insignificant, because we make another table in the regression analysis that tell us based upon the p-value or based upon the test statistics that either our variables are significant or not. If we talk about the relationship graphically, so we have simply two types of relationships, linear and curvilinear. For the linear relationship, we have a straight line And for the curvilinear, we have hyperbola, parabola. So this relationship it shows that positive, and this one is showing negative. Again, these are positive, these are upward and downward. Here a straight line is best fitting the data, and in this graph the curvilinear line is best fitting the data.